So in Chapter 6, we're going to continue talking about conditionals and loops. Chapter 6 focuses on the switch statement, the conditional operator, the do loop, and the for loop. The switch statement. The switch statement provides another way to decide which statement to execute next. The switch statement evaluates an expression, then attempts to match the result to one of several possible cases. Each case contains a value and a list of statements. The flow of control transfers to the statement associated with the first case value that matches. So here's the syntax of the switch statement. You have the reserved word switch, and then this is where your expression is going to be. And then case is essentially going to be if this expression evaluates to this particular case. If it does, then you're going to execute the statement inside of that case. Now, once you've matched, then you're going to execute the remaining statements unless you put a break statement. And I'll show you that in a programming example. So often a break statement is used as the last statement in each switch statement list. A break statement causes control to transfer to the end of a switch statement. If a break statement is not used, the flow of control will continue to the next case. Sometimes this may be appropriate, but often we want to execute only the statement associated with one case. And here's an example of the switch statement in use. So they have an option. So option would be a char. And then if this char matches capital A, then the increment A. If it matches B, then the increment B, C, and then they'll increment C. Now they're using breaks here. So that just means that once the statement is ran, you're going to leave the switch statement. A switch statement can have an optional default case. The default case has no associated value and simply uses the reserved word default. If the default case is present, control will transfer to it if no other case values match. If there is no default case and no other value matches, control falls through the statement after the switch. So that just means that if it doesn't find a match, it's not going to do anything. The type of a switch expression can be integers, characters, enumerated types, or string objects. You cannot use a switch with floating point values. The implicit Boolean condition in the switch statement is equality. You cannot perform relational checks with the switch statement. Other cases perform the equality check. See gradereport.java. So in this program, they created integers for grade and for category. They created a scanner object. They prompted the user to enter a numeric grade. They stored the numeric grade into the variable grade. Then they set category equal to the grade divided by 10. Then they pass category to the switch. So if category was a 10, they print out a message. If it was 9, they print out a message, and so on, right? So once they got to 6, they printed out some statements, and the default was printing out not passing. And notice each one of these is using break. So after the statement executes, then you leave the switch. Here's a sample run. Enter a numeric grade. They entered 91, and then for 91, the category was 9, so they printed out well above average. Excellent. So I created this program to demonstrate the switch statement. In this program, I'm going to use a scanner class. So I imported my scanner object, and then I instantiated an instance of my scanner object. Then I created a variable to hold a char. The name of the variable is option. Option is going to store the user input. I'm presenting the user with this menu right here. So I'm simulating a role-playing game. So let's just say we have a character who's walking down a road and he comes across an enemy. I'm presenting the user with this menu. He can either attack, use magic, use an item, or run. Then I store the input into the option variable. Now scan.nextLine is a string, and I'm grabbing the first char off that string by using char at 0. And then here is my switch statement. So I'm passing the char into my switch. Now remember, the cases are all equality. So if option is A, then this statement will execute. If it's M, we're going to execute this statement. I here, R here, and then we have a default case. So if none of the above match, then we're going to print out this statement right here. Now notice I'm not using a break statement. When we don't use a break statement inside of our cases, that just means whenever we have a match, we're going to pass through. For instance, if we have a match on I, we're going to print out this statement, but we're also going to print out this statement here and this statement here. Now that's not the desired behavior for this program, but I'm going to go ahead and leave it like this so that we can see how it behaves. So I'm going to go ahead and compile and run this program. So here's my menu. I'm going to give an invalid option. I'm going to use a 3, and I get the output not a valid option. This time I'm going to choose the option to use magic. And you can see that we had the pass through, so it matched on magic, but it also printed out all the other statements. So this is what happens when you don't use a break. So I'm going to go back to my program and add in a break. But just one more thing I wanted to show you. Now let's just say I want to attack, but instead of using a capital A, I use a lowercase a, and I get not a valid option. So what happened is, if you look at my switch statement, I'm only matching on capital A. I'm not matching on lowercase a. So I'm going to update the switch statement to handle lowercase and also break so that I'm not printing out all the other statements once I find my match. Okay, so I updated my switch statement. I went ahead and used breaks on all my cases so that whenever I execute the statement, I leave the switch. The other thing I do is I added a new case to handle the lowercase version of the option. So now I'll accept uppercase A or lowercase a for attacking, uppercase M, lowercase m for magic, and so on. So this is what we can do to accept both the uppercase version and the lowercase version. Now I'll show you a simpler way to do this after I test this program. So I'm going to go ahead and compile and run. So I'm going to use the lowercase a to attack, and if this works correctly, then the only output I should see is that I'm attacking. And there you go. So using a lowercase a now works for attacking. So does using a lowercase m, lowercase I, and I enter in any value that's not an A, M, I, or R, then I still get the invalid option. So another way of handling char case is we can actually come over here to our string where we read the input, and we can do something like invoking the to uppercase or the to lowercase method. So if I invoke to uppercase, this variable is always going to hold an uppercase letter. It's never going to hold a lowercase letter. So I don't even need my option for my lowercase. And it prevents us from having to handle that inside of our switch. So I'm going to go ahead and compile and run this program and test it out. So I'm going to enter a lowercase r, and the lowercase letter worked. So changing the case as you read the input from the user or adding a case here inside of your switch, they both work the same. You can handle it either way. I just prefer to do it this way because it's less things that I'm having to type out.